Welcome all to this lecture session, serial input, serial output, right shift register. I am M. Saraswati and today we are going to discuss about the working of right shift register. So for this discussion, I have taken 4 bits and you can see the logic diagram. This is what is the logic diagram for 4-bit serial in, serial out, shift right register. And already we have discussed for registers we have to use D flip-flop because register is shift register. You are going to just shift the data. There should not be any change in your data. So that is why we are taking D flip-flop, where D flip-flop will not change any of the data. So it is going to give us a delay. Okay. Now at the starting, what we have to do is we have to confirm that all your registers are 0 because we know flip-flop is a storage element. So first you have to clear all the data. So I am making all the flip-flop outputs to be 0. So QA. So QA, this is your first bit, QA, QB, QC, QD. So all the 4 bits has become 0. So how you have to give that is by giving the input. So first you give the input 0 here and make all your flip-flop outputs to be 0. After that, this will after that confirm whether your bits are 0 and confirm whether your outputs has become 0. After that, you have to start giving your clock pulse. So when your clock pulse is 0, you make all your outputs of the flip-flop to be 0. Okay. So now next. Now we are going to give the first clock pulse. So first clock pulse is given, clock pulse 1. Okay. So for first clock pulse, your flip-flop A alone will respond. Okay. So you can see this alone will respond, flip-flop A. Now, once clock pulse is received, the data input what you are giving, the data input will be given to the first flip-flop, that is A flip-flop. Okay. Now this one will go to DA. Okay. The one will go to this one. Now will go to DA. That is input of your D flip-flop. Then once the clock is given, this data input will be accepted by the flip-flop and this data will move inside and it is going to give some delay, and after that delay the output will be marked as 1. You can see the output as 1 and you are giving only one clock pulse. So only first flip-flop will be working. Why? Because it is being serially connected. So it has to work one by one only. Okay. So that is why for one clock pulse, only first flip-flop will be active. Okay. You can see. You can see this. Your data input is moved to QA. Now QA has become 1 and the QB, QC, QD is as such. Okay. So all these are 0 only. Okay. Now you can see when we check the output of this register, now you can find QA alone is 1, QB is 0, QC is 0, QD is 0. Okay. So this data input what we have sent for the first clock pulse, this changes your QA to 1. Okay. So first clock pulse is over. Now You can see the movement. Now we'll go for the next. Okay, now second clock pulse is given. Okay, now first clock pulse and second clock pulse. Now first clock pulse, once you give your first clock pulse, we saw that QA has become 0. Okay, now once you are giving 2 clock pulses, 1 clock pulse will be taken for B, 1 clock pulse will be taken for A. Okay, once you apply 2 clock pulses, what will happen is this QA which you have got as 1, this will go as the input for QB. Okay. Now, once this QB is receiving 1, once your flip-flop is getting the input itself, your output will be displayed. Okay. So now you can see this 1 will be accepted by DB once you give your clock pulse. After that, you can see your QB from 0, it will become as 1. Okay. Now, after that, once again, you have one more clock pulse. Yeah. So this clock pulse will be taken for A. Now you have your D in as 1. This 1 will go to QA and this QA will respond, and you are not changing this input. D in we are maintaining as 1 itself. Okay. So your QA also will be 1 only. Now when you check your output, you can see you will be having your output as 1100, and you can see this one QA input. You can see this now. QA input is taken to QB and it is given as the output of B flip-flop. So QB has become 1 now. Okay. Next, you can see how was this movement. You can see the animation here. DN is becoming 1. Okay. Now next, let us clear this. Okay. Now we'll go for the next. Okay. So I'm going to apply 3 clock pulses. 1, 2, 3. Okay. So if I'm applying 3 clock pulses, now 3 flip-flops will be active. A, B, and C. Okay. So 3 flip-flop is going to work. Now how it will work? QB is already 1. Now this third clock pulse will make this DC to take the input. Okay. So 1 clock pulse for A, another clock pulse for B, and another clock pulse for C. Okay. So all the 3 flip-flops will be working, and you can see already QB is available. So what will happen is QB is equal to 1. Once clock pulse is received, now DC will become 1. Now this will become 1. After that, this flip-flop will work and it will give an output of QC equal to 1. That is what is given here. From QB, it is being shifted to QC. So that is what you call it as shift. QB is given to QC. Okay. And the second clock pulse will make B to work. Yeah? So QA will be taken as the input. Now QA will be taken as the input for QB. You can see it has been interconnected. So once clock pulse is received by the flip-flop, the B flip-flop will start working. So it receives an input of 1 and it will give the output of 1. That is why QB has become 1. Next, you can see we are not changing this portion. So we are having this D in as 1 only. Okay. So now this clock pulse makes your A flip-flop to work, and this 1 will be taken by DA, and this flip-flop is going to work, and after some delay it is going to give you an output of 1. Okay. So this is what is your case. Now can see. You can see from QB it is moving to QC, and from QA it is moving to QB, and from DEN it is moving to QA. Okay. So your output has become QA1, QB1, QC1, QD is 0. So if you want this data, you can stop. Otherwise, I want QD also to be 1 means you go for one more clock pulse. The same pattern. Okay. So you go for one more. You go for one more clock pulse. So 4 clock pulses. First clock pulse for A, B. Second clock pulse for B. Third clock pulse for C. Fourth clock pulse for D. Okay. The same pattern. So from QC, it will be moved to QD. From QB, it will be moved to QC when clock pulse is applied. From QA, it will be moved to QB when clock pulse is applied. And from DEN, it will be moved to QA. Okay, so this is what is your right shift. You can see you are giving your input at the left side and your data are moving towards your right side. That is why it is called as right shift register. Okay. So we have made a table here. When DN is 1 and you are not applying any clock pulse, all your flip-flop output is 0 only. When your first clock pulse is applied, when you go for applying your first clock pulse, you can see this DN will become the output of QA. Okay, so this DN will be given to A flip-flop and you will get the output of A flip-flop QA equal to 1. Okay, so once you apply your second clock pulse, when you apply second clock pulse, what will happen? This QA will be shifted to QB. Now this QA, whatever you are having, no, that will move to QB, and whatever you are having DN, no, this DN will be moving to QA. The same you will be having your shift. Okay, when you apply your third clock pulse, this QB will be moving to QC and the QA will be moving to QB, and this DN previously is there, no, that will move to QA. Okay, that is how there will be a shift. When you see your data, you can see this is what is your output 1110. Okay, so in each stage, what is the output that we have placed? Okay. So this is what is your serial in, serial out register. Okay. Thank you.